So let's build a FIRDS database. To start with, let's take a look at the official instruction by ESMA, how to do that. FIRDS instructions. This is the document that is published by ESMA of how to build this database. So ESMA publishes 3 types of files. First, you have the full files, which contains all the active records. That is published by trading venues. Then you have the delta file, which every time each field in our TS23 reports gets updated, that will be included in the delta file. You also have the invalid record file and the cancelled records file. These are pretty much irrelevant for us today. So the goal of building this database is that we're going to consume one full file from the starting point of the period that we want to build. For example, if we've been going back for 5 years, we want to build a full file starting perhaps from February 2021. So we don't need a full file we don't need every single full file essentially. So we just need one full file at the beginning of the period and all the delta files that follows after that, right? And here we have the instructions on the official XML formats of the file. And also in 3.4, they give us exactly the API and how you can query the API, right? So here we have the code. The code is actually very well written by Gemini Pro, and it was very well tailored by our need. So you can essentially see on the left-hand side, this is our Jupyter Notebook code, and the right-hand side is one of the snippets of the delta file. And to build a database essentially follows 4 steps, and they use very simple packages, etc. Right? The request package, the SQLite package, which help us to build a SQL database, and a zip file, which is used to unzip the files that is published by ESMA, and then we parse it into a tabular format using the elementary package. Right? So the first step is to create a database. We use the SQLite package to create the first database. So we give it a name called FIRDS History 48 Fields, because we want all the 48 fields in our TS23 reports. Then we create the names for all of these databases. So essentially this database in step 1 has no data. We're just creating the schemas of the database, and we create the tables of the database. So here we have specified exactly all 48 fields. The second step is to fetch and download links from ESMA. This is the API that is officially created by ESMA, how you can query the full files and the delta files that followed after that. And then we have the helper function. The helper function essentially tells us, okay, once you get the XML file, where you are going to extract the data from. It's very important that we set 2 types of functions. The first one is called getText. Second one is called getAttributes. The difference between getText and getAttributes is that getText is going to take the values in between different XML tags, kind of like the data is being sandwiched by 2 different XML tags. For example, if you look at the example on the right-hand side, let's say the interest rate, the forex rate, I believe, is hugged by 2 XML tags, right? Which means that when you use the getText request functions, you can take the values between the sandwiched 2 XML tags. However, there are different attributes, such as, let's find an example. For example, here, when you use getText for these attributes, instead of getting the numbers, you will essentially can query to get the metadata of this field and get the currency instead, right? So that's the differences. So we use both helper functions to extract the data. And the third step is to download and process the XML files. Here we have defined a process function to parse the XML files, and here is to essentially saying that, okay, once we have downloaded XML file, which field of the SQL databases is connected to which text in the XML file. So for example, you can see here the most important structural items are recorded here. So we have the ISINs, the make code. The ISINs called the ID. So if I copy the ID here, you will see all the ID hugged between each other are the ISINs. For example, if I see let's get the, which value do we want? Let's say commodity derivative indicator. If I copy the commodity derivative indicator, this is essentially telling that the code that whenever you see an XML tag that's called commodity derivative indicator, we take the value as false and we plug it in as a pandas data field called commodity derivatives. So we divide all the queries by several sections, right? We have the main ones, we have trading value attributes, then we have debt specific attributes, then we have derivative based and underlying attributes, and then we have forex, interest rate, and commodity details. Then we have different technical publication attributes, which is very important. So here we have the publication from date, so where this record has been published, and the relevant trading venue. I think what's mostly relevant to us is also, for example, here, this is the first date of trading and the termination date. So in this case, we can know the ADD and terminations of a specific records. This is very relevant to our Count for 1-2 investigations. And then once we have done that, here we have all the pandas data frame we have collected using these functions, and then essentially we're mapping this pandas data frame to the different fields we have in our SQL database at a one-by-one relationship. And here it says if the file type is a full file, we're going to connect them one by one. If it's a delta file, we're going to connect them one by one as well. The last step is to do a historical run loop. So we first starting with each, if we take a period of days, we take from the first day and we try to find a full file. And if we find a full file, we're going to download it and parse it. And then from that date, we're going to find a delta file, and that delta file is going to add records on top of that full file. So for example, whenever we see a delta file, it's going to see that we have a from date and valid to date. The from date essentially is the publication date, when this record has been published, and when this record has been valid until which date. So for example, if a field is going to be updated, the new record is going to be created and old record is going to be inactive, and old record is going to be milestoned. This is very similar to the out timestamp in our databases. And the second thing is that once a field of a reference to the table has been updated, the latest record flag is going to be set to 0. So 0 means they're inactive. And the latest records, which with the latest updated values published by trading venues, are going to have the value as 1. So what is that telling us is that if we're filtering the latest record flag equals to 1, which means that we're only taking the latest values and we're not taking the past values. Obviously, the historical run loop, at the end of our code, we have the date range that we want to query. So this is actually taking a lot of time. This is not bound by our network speed or bound our CPU, but because we're doing this sequentially, we're querying one file at a time and parsing them one at a time, is actually processing quite slow and is generating a lot of data. There are essentially much faster ways to do it, which is that if we downloading all the files at the same time, and we store them in our RAM, and then we can execute the commands together instead of sequentially. That's going to be much faster. But I think for our purposes, it doesn't make any concerns because we only run this one at a time, right? We only consume one Delta files at a time. So once that first initial very long run, a very large data generation, after that, the running speed should be quite insignificant. So let's take one example. Let's say we want data from 15th of February until today, right? Let's run this code. So as you can see, it's trying to find a full file from 15th of February and 16th of February. Nothing goes on up until 21st of February, which is a 21st of February. It is a Saturday, right? So Asma actually publishes their full files on a Saturday. So it's detecting that the first full file is on a Saturday, and then we're trying to download it and process the full files, and sequentially we're going to download and process and update the Delta files. Let's give it 10 minutes for this to be run. All right, the database has been built. Let's go to our database. You can see that it's quite large. So yeah, it is quite large. 1.38 gigabytes for the last 10 days. So that is quite a large database. Let's open the database, and we can open a schema, and we can see that we have all the fields that we wanted. Let's put it back in the middle. We have all the fields we want. Let's do a quick rundown of how many latest records and inactive records we have. Maybe because I didn't group by. Right, that's more like it. So we can say half-half. We have about 2 million records that is active with the latest record flag as 1, and about 1.8 million that these are already inactive. So this record has been already updated, but they are still useful because they give us a historical snapshot of the data, even though they are inactive, but they were active at the time when it was published. So when we receive regulatory inquiries, we can essentially use this as an evidence that at the time when we report this report, the data was accurate, right? Let's check a few instruments. Select ISO from our first database. How should I select everything? Where mic is equals to, let's say MTA. Let's limit to 1,100 records. Oh, they don't have many records. Let's get URX over here. So URX actually have a lot of records, and as you can see, we have the ISIN, the venue main code, we have the full name of the instrument, we have the short name of the instrument, and we have the ATD and termination date, and we have expiry date. All the information that is available in FIRDS, they will be in here from the period that we have selected. So let's take one example as well. Okay, let's use a different query. Check one ISIN, for example, where ISIN equals to first ISIN that we talked about. We can see that we have one record. The venue has published this reference data on 21st of February. The ATD and termination date is 20th of February until 2026. So let's verify this information on FCA FIRDS. And the reason that I'm checking for FCA FIRDS instead of ESMA FIRDS is because ESMA FIRDS website, essentially it never works. So where it's here, let's go to here, let's search, and let's select also the publication date, the publication from date. Here we go. So for this instrument, we have first trading date, termination date exactly as specified in our database. So here we go. So what is the limitation of this? The limitation is that since we only selected 20 days in the past, or perhaps even less than 20 days in the past, we will not have records that has been already milestoned, which means that, for example, if a product has been already terminated and they were published before this date, they will not be sourced in the database because they neither exist in a full file because they were not active in our first full file, and this record has not been updated following the first full file, which means that these records wouldn't exist. But most of the records, not most of them, so all record that is still active will be there, and all record that has been updated since the first day we have chosen will be in a database we have been built. So to do this properly, we'll probably have to select a 5 years data frame, but that's going to probably take 2 days to run this. And we're going to have probably hundreds of gigabytes of data, but hopefully we're going to be able to do it. All right, thank you very much.